Welcome to EDU World Space.
All right, we have a primary alkyl halide and potassium cyanide in a polar aprotic solvent. Right, that's going to be an SN2 reaction, the mechanism for which is shown here, and the product shown here. Next, we have a primary alkyl halide with sodium hydroxide in water with heat. Okay, heat is going to favor elimination over substitution. So this will be with a strong base, an E2 reaction, the mechanism for which is shown here. Now we've got a tertiary alkyl halide in water. This is going to be a solvolysis, but note that water is polar protic, which is going to favor elimination. So in terms of the mechanism, we expect bromine to leave, creating a planar carbocation. Then we expect water to act as a base on a neighboring proton. And generate an alkene, making this an E1 reaction. All right. Next, we have an iodomethyl cyclohexane, and we are reacting it with a strong base and nucleophile, ethoxide, sodium ethoxide in ethanol. Okay. Again, polar protic solvent is going to favor E2 over SN2, right? So we should expect an elimination reaction. In terms then of the which side this elimination will take place on, with one of the hydrogens over here or with the hydrogen under here. So long as they are anti to each other, we'll be fine. And we know there's a preference for more substituted alkene, so it'll be better to form the alkene on that side with the methyl group, so that our product then becomes that more substituted alkene and not, this is E2, and not that less substituted alkene. Okay, finally, we have an iodoalkane. We have sodium thiolate. In a polar aprotic solvent, strong nucleophile, weak base, polar protic solvent, secondary substrate, tells us that this will be SN2, and the mechanism that'll be confusing if I draw it that way. Will be a thiol with inverted stereochemistry.